Thank you.
Whalley. Okay, good. Hi, everyone. Can you hear me? No? Okay. Hi, everyone. I'm back. So tonight I have the great honor of introducing Andrew Whalley, who's the deputy chairman of Grimshaw Architects and the partner in charge of Grimshaw's New York office, which he helped establish. Grimshaw, if you don't know, is one of those offices whose work you think you know until you take a closer look. The moment you peg them as interested in the repetitive and the skeletal, such as their amazing and groundbreaking Waterloo Station project inserted angularly and directly into a gritty and bustling part of London, you have to immediately deal with the Eden project and its lightweight, bubbly spheroids containing not train tracks but acres and acres of plants. The moment you label them as high-tech and concerned primarily with the machine aesthetic that combines infrastructure and structure in the creation of massive public works projects or factories, you remember the beautiful poetry of Sir Nicholas's very first project, the Service Tower, for a youth hostel which postulated an endless ramp of bathrooms and showers that becomes a social space for scantily clad youth in search of an empty facility. We would know that here. Or the wonderful spaces of the houses at Grand Union Walk, which took the Corbusian ideal of the double-height space and infused it with light and opened it to the exterior through a completely operable facade some 25 years ago before Shigeru Ban's Shutter House, by the way. And perhaps most importantly for us tonight, the moment you acknowledge Grimshaw as a quintessentially English firm, somewhere among the Fosters and Rogers and Hopkinses, you realize that they have become not just a global firm in the model of those others, but also an intensely and unequivocally New York firm. Here, Grimshaw has built what is perhaps the absolute best example of what contemporary affordable housing can be, with the Via Verde building in the South Bronx, which I had the pleasure of visiting a few years ago, and we had a talk about here. They're working in the heart of downtown Manhattan, building the Fulton Center with a massive post-9/11 federal grant, and they recently completed the renovation of the Queens Museum as part of Mayor Bloomberg's Design Excellence Program. In many ways, you cannot have a more quintessential New York resume than that. The way that Grimshaw has continued to create quality work sensitive to local conditions and truly as part of the local community is a new model for global practice today and stands in direct contradiction to the image of the starchitect jetting around the world from place to place. In addition, even if you are only mildly aware of Grimshaw, it is clear that the firm is a working collaborative, of course with an influential and charismatic founder in Sir Nicholas, but also the kind of place where a partner like Andrew Whalley and his talented team can truly make his own independent mark on the work locally. Andrew has been working with Grimshaw since the earliest days of the practice and has been partner in charge of an amazingly diverse range of projects, including many of the seminal projects I have mentioned. Beyond New York, Andrew is responsible for all the projects in the United States and has also led the development of the Grimshaw portfolio in the Middle East, setting up a Doha office in 2011. Today, Andrew will be speaking specifically about the influence of nature in the work of Grimshaw, which is something I'm personally very interested in, and I look forward to hearing about. Indeed, it promises to open up yet another lens through which we can view the practice and the work. Please welcome Andrew Whalley tonight.
Thank you. Thank you very much for your kind words. I don't know if I can now live up to everything you said. I will start off with an apology for being a little late, such as, New York is just like London, a little bit of rain and there are no taxis to be found and the city changes. After sort of many years in both cities, you'd think I would learn. But today was actually supposed to be a double act. Often I do lectures with Nick, and the two of us do, our double act together. Unfortunately, Nick broke his foot a little while ago and obstinately refused to wear the things he should wear and then managed to break it again. So finally, the orthopedic surgeon put him in a gigantic boot and told him to stop traveling. And I was with him last week, and he was actually thrilled with it because it has lots of dials and knobs on it, you know. So of course that appealed to his technological self. So he couldn't be here. So what we did was record a little the intro that he was going to do anyway. So I'm going to start off from a few words from Nick.
Well, hello, Columbia. I'm really sorry not to be with you today because of my broken foot, which I hope will be okay in a few weeks' time, and I'll get across to New York in a flash to pick up on all our work going on there. As you know, our firm goes back quite a long way, and I suppose if we think of our beginnings in the 60s, we kind of established ourselves very much as a kind of nuts and bolts firm, greatly interested in detailing how things went together, the structure involved, and that was very evident on our first project, the service tower in Sussex Gardens in Paddington in London, and kind of expanded gradually in trying to introduce modern materials and, in some ways, industrial techniques into different fields of architecture. So we moved to our block of flats in Park Road, which was built out of necessity. I had nowhere to live, nor did my partner, and the idea of building a building for ourselves was quite appealing. We both lived there. I lived there for 6 years, and then the firm kind of started expanding quite rapidly. We had kind of quite a evangelical approach to pushing new materials and trying to sort of look to the future, and the idea of industrialization and factory-made parts was a very important thing to us. We got the big job, or possibly one of the best jobs in Europe at the time, which was the international train station at Waterloo, connected to the Channel Tunnel. Very exciting job to win. We fought tooth and nail to get it, and it took us, well, best part of 5 years to do, finishing it in '93. At the same time as that was going on, we won the competition for the British Pavilion in Expo 92 in Seville, and that whole project was based on the idea of energy saving, sustainability, and recognition of how architecture could work to help climate issues. Spain, Seville particularly, being the hottest city in Europe, but people had lived there quite happily for centuries, so it wasn't an impossible environment to live in. We had to show, well, we tried to show how modern materials and modern technology could be used to make an acceptable environment. So there we are, sitting with these two pretty quite experimental, quite daring buildings behind us, and we started to expand and be recognised abroad. It drew us to our first building in America, which was the Plant Science Centre in St. Louis, I should say, for Americans present. And that building itself was an interesting exercise because we had the key thing, which of course was the laboratories, but we had to use the building to try and make an acceptable environment for the people working there, mainly hundreds of PhDs, who were sort of in a pretty remote site in terms of America and in terms of St. Louis. And we had to make their life acceptable. So we made a quite a grand environment in terms of an atrium and a really nice lecture hall and library and so on. But we tried to, although this was a highly modern building, we tried to make it a really humane background. Right? So it was technology working for human beings, in my view. And I think Andrew will be saying a bit more about this later on. But our life in America then went on, and as you know, we're about to open the Fulton Center, which is a huge transport exchange downtown. We've done the Queen's Art Gallery, converting the ice rink that was Flushing Meadow into a fine new art gallery. We've done Via Verde, which was quite an experimental scheme in low-cost living with planting on the roof. I suppose a lot of our work has been in the field of public buildings. I like to say the public good, buildings for the public good, but a lot of it has been in transport, which the public does experience on a very big scale. And I don't know, I may be naive, but I feel that if people go to work every day and they pass good details, it makes them feel better. If they see a horrible, cheap, bland building, it makes them feel worse. Perhaps I'm naive, perhaps that's a subject for discussion. Perhaps that's something Andrew might dwell on a little later on. Anyway, I just would like to end by saying that we're a dedicated group. We have 16 partners, plus me, and we share everything. We have different interests, but basically we live on our wits. We share our profits. We have no equity in the firm, and basically we kind of live out of excitement and interest in architecture. And I hope some of the things Andrew will be showing you will reinforce that idea. Thank you very much. I look forward to seeing you all in a few weeks' time.
I should say thank you, Nick, for the intro. So Nick mentioned the New York office, and I thought I'd just start there. And in my talk on kind of inspiration from nature, I've tried to also focus a lot of the projects from our New York portfolio, as I thought that would give a kind of greater relevancy. Maybe this is slightly a kind of masked advertisement for graduates, but we've actually had some brilliant graduates join us from Columbia over the last few years. And we started in 2001 with 2 people in downtown in Tribeca, and really through a whole series of different projects. As Nick mentioned, a lot of public projects and a lot of projects that came through the Bloomberg period. We've grown so up to 100. And so we had to find a new home a few years ago, and we took the step, almost, I guess, early adopters, to move into West Chelsea, into this warehouse building. And we've always enjoyed having a street presence, so we built a kind of gallery space and workshop, and then converted the whole top floor as one studio space. So we can get all of our architects and industrial designers all on the one floor working together. But it also allows us to have a nice large workshop where we can manufacture full-size prototypes. And it's used from everything from model making to testing furniture design by our industrial designers. And I think we just really enjoyed being immersed in the city and, being part of such a vibrant city. And so in our gallery space, we host lots of different events and panels. We've got an urban research unit that's been running for the last year with some very exciting discussions and topics. It has its own website. And more recently, we sponsored and introduced the Royal Society of Arts Student Design Awards. So it will be going into its third year next year. And of course, famously, Joni Ive of Apple was one of the kind of first winners when it was in the UK. And so through that, a group of us offer paid summer intern positions for students. So if you're interested, the brief will be coming out on that, I think, in the next month or so. But the other thing we do from New York, and so I should stress that obviously London was the first office, but we work very much as a kind of network. And London and New York in particular work very much in tandem. Is that we publish our research book, Blue, and we're just working on Blue 3 at the moment, which is on the kind of future city and urban design. And our industrial design unit is primarily focused, where you've seen probably all the street furniture in New York, the bus stops and newsagent stands, but also everything's done from light fittings to new furniture systems. So the emphasis of my talk today is really about our inspiration from nature and how we draw upon that as a kind of design kind of guide, if you like, to look at the kind of problems and challenges that face us all. So I'm going to start off with a couple of statistics that I think you'll all be very familiar with. Starting with, of course, 2008, where we switched from being a rural civilization to an urban civilization, where more than half our population, 3.3 billion people at that time, were living in cities. So that was a big switch. But more importantly, in our kind of lifetime, there's an even greater change with a continued growth. And as I think many of us have heard, that basically another kind of 30% increase in population growth, but all of those actually effectively living in cities. So we'll have a situation where 2/3 of the population are in cities, which means physically we have to double the size of every city or add, and principally it's adding new cities. So really I think we're into a kind of interesting set of challenges. I mean, as an architect, and I think we all share this, we all prefer things graphically rather than statistically. And these are wonderful maps that are produced by the University of Sheffield that map statistics in different ways. So this is the way we're used to seeing the planet mapped from a 3D to a 2D projection. This is a different way of mapping it, instead of landmass, by population. And so, of course, what you immediately read is that half the population are living in one kind of part of the planet, on one side, and so we have some very dense areas of population. But if you remap it by consumption per capita, it reads very differently. So immediately you see the US has a little bit of a weight issue, and so does Europe. And of course, we're consuming 5 times the amount of materials and resource that the planet could actually support if everyone was to consume at the same rate. And it only works because most of the planet are consuming a fraction of that. So if you then remap the planet and look at where are all these cities going to be, or these new cities over the next 30 years, it gives you again another picture. And so what you see is most of those new cities are obviously in part of the planet that's currently not consuming at the rate we're consuming. So it's a really very interesting challenge. But I find it even more interesting to then map against time. And to think of the planet as 4.54 billion years is a difficult thing to comprehend, and what our impact has been on it in that time. So if you think of the planet and those 4.5 billion years as a year, then it's much more understandable. So you look at it, basically humans appeared, as far as we can tell, 15 minutes before midnight on the last day of the year. And the start of recorded history is actually 30 seconds before midnight. But the most important part is the Industrial Revolution within the time frame of a year on the history's life, happened 1 second before midnight, which means the whole impact of kind of global warming and what we've managed to do over the last 2 generations happened within about a blink of an eye within a year. So we achieved this within a blink of an eye of a year. I was tempted to talk about weird architecture, but I'm not tonight. So I am going to talk about nature and things that I think could inspire us to look for solutions. Now, for me, many years ago, well, not many, a few years ago, I went on a research trip in the Amazon. We've done, obviously, the Eden Project. We've done some other similar projects. And I had the good fortune to kind of explore and spend time in that part of the world with a very famous biologist called David Campbell, who's written many books. This is David here, on the Amazon. And of course, like many, I'd rather foolishly believed that the reason why it's the most biodiverse part of the planet is because it has a very kind of rich set of nutrients that can support this very rich, biodiverse life forms, plants, animals, insects, etc. And of course, this tree tells us all that actually it's all built on a few inches of very sandy soil with almost no nutrients, hence why you have buttress trees and so on. And the reason it can actually survive and support that ecosystem is really 2 main parts. One is that it's extremely efficient in how it uses resources, but also it's ingenious in how it uses those resources. And for me, those are the 2 areas we need to focus on. It's not just efficiency, but it's ingenuity. And if you ever get a chance to read David's book, The Land of Ghosts, it's a very inspirational piece of writing. And of course, you find nature and its inspiration through architecture, through generations. This was a building that really inspired me when I was a student at the Macintosh in Glasgow. And it's Keble Palace, and it's a very lightweight glass structure, entirely kind of inspired by the Victoria lily, which you see on the right. And it is literally a single skin of glass and wrought iron, yet it spans a great distance. And of course, you often find in botanical structures in particular, they're very inspired by natural forms, which we'll come on to later in the talk. So I'm going to go through a few topics, and as we start a little late, I'll go quite quickly. But the first one is maybe the most obvious one, harvesting the sun and energy systems. Nick started by talking about the British Pavilion in Seville, and that was one of our first projects, I think, that really looked at how you could use environmental systems and what that might mean as an architectural language. So it was one of the first times PVs had been used as an active part of an energy system on a building. And this is actually Nick's very initial concept sketch as we started the design competition. And you see he still works in Fahrenheit, which is very nice. But the outside is 102 in Spain, generally, often. And the idea was creating layers and buffers rather than trying to condition a space and trying to create an ecosystem that really also learned from the prevailing traditional architecture, where, often what you find is there's an understanding on how you can create microclimates using the prevailing materials and working within the environmental constraints. Another example of a project looking at how you can actually use, if you like, solar gain as part of an environmental system. This is another kind of experimental project we did. And of course, you'll know that PVs aren't particularly efficient. They're only 18% to 20 maybe coming up as an efficiency. Whereas if you can actually use heat, it's a much more effective way of harnessing the sun. And so we were really intrigued on how you could actually effectively create a roof structure that might almost kind of, through a biomimicry way, use photosynthesis to create energy and to kind of run the building systems. And here we were using very efficient solar collectors that are kind of up to 80% efficient to generate a great deal of heat that could then be used as part of a kind of both a heat storage system for the kind of colder part of the year, but also as part of an absorption chilling system. So we were using the heat to cool the building. And it was a very much kind of experimental idea, but it's something that we're now taking on and actually now using, particularly in the Middle East, as part of a kind of energy solution where you can actually use the sun to cool a building and create a building that can run almost as efficiently as a building in Europe. So for my next theme, natural structures, looking at how we kind of draw upon nature, I guess, as an inspiration for efficient and very lightweight structural forms. So again, Nick mentioned the Eden project, which is a project that I worked on for about 10 years from conception to final execution. And again, there is actually a connection to New York, because when we set the New York office up, we set it up with a kind of core team that did the Eden project. So this was to celebrate the millennium. It was to look both at the kind of UK's interest in botanical gardens and research into plants, but also to look forwards to a kind of future where we had an understanding of our relationship to the planet and the important part that plants play in that. So our brief was to create very large enclosures where we could create an entire tropical rainforest, the humid tropics, and different environments. And the site was a disused clay quarry in Cornwall, which is in the southwest of England. So it was quite a challenging site. It won't surprise you, it was used often for science fiction films because there wasn't many plants and it was this sort of white lunar landscape. So we started with this as a site, very challenging, and the contractor looked at me and said, well, man has spent 100 years digging this very big hole, you're now asking me to fill it and reconstitute it in 18 months. So often, it's a challenge, but that's what we did. But again, for the enclosure and the buildings, the inspiration was very much about natural forms, and you see that throughout the buildings. I had an interest in a material called ETFE foil, ethylene tetrafluoroethylene, which is a polymer that's very lightweight, very strong and transparent. So again, we were really searching about what would the new generation of kind of greenhouse be that created the maximum enclosure with the lightest and minimal kind of use of material. And you find, for instance, the reason it has a hexagon structure is creating the maximum kind of enclosure with the minimum number of structural elements or lines of structure. And the whole building is like a series of interlocking, effectively soap bubbles. So we took the site, the quarry, and modeled it in 3D and actually generated the buildings out of a series of spheres and then took those spheres and interconnected them and then molded the enclosure and the topography. And that's how we generated the whole form of Eden. So it created, of course, the kind of maximum efficient enclosure, maximum space to the minimum surface area. And again, throughout the building, you see how the structure is informed by kind of natural forms. So the way, for instance, each of those elements join together is exactly the same way as you find a dragonfly's wing works, with the same sort of cellular structure and connections. And that was the kind of structural form, but also we then used that form as part of the environmental system, where we looked at and modeled how air would move around the building. You see here, the size of the spheres you see here are to do with the velocity and the color is to do with the temperature, and looked at how we could actually use the building itself to actually direct the air and condition the space. I have to admit, it does look a little bit like a family planning video, but anyway, we'll move on. So, it's, but the ultimate was it was a very lightweight, very efficient structure with the minimum of environmental kind of control systems. So the steel tubes, the largest tube we had covering the 120-meter span was only 8 inches in diameter, so quite lightweight. But ultimately, it was really about ingenuity. It was about using the topography as half the architecture. So really what we did was we actually created the lightest weight enclosure to encapsulate this beautiful natural form. And it's actually the topography which is the kind of vibrancy of the building. And the end result was that the whole building of this building weighs less than the air inside the building. So it means that you're using a fraction of the material that a kind of glass and steel building would use. So it's also, environmentally doing things as efficiently as we can. And we've had a great ongoing relationship with Eden, where we've worked with them for 12 years now, doing many buildings. One of the latest is this building down here, which is the educational core. And the lovely thing is that they have, at times, up to 2,000 school children a week coming to do some of their science curriculum at Eden. And you can imagine it's a much better way to inspire a child to be interested in science for them to spend a day in the rainforest learning about biology than it is, in front of a blackboard. So the idea of the building was to use the building's form itself as part of the teaching tools. And so the whole geometry and structure of the building uses a Fibonacci sequence, which is called the phyllotaxis spiral, which is a geometry you find throughout nature in that it's the most efficient way of packing in the maximum number of cells. And so it's the way, for instance, you'll see a sunflower or many flowers growing and how they grow outwards. And so that's the geometric sequence we use to create the glue-laminated roof structure for Eden. And so the idea was that the building not only provides the facility for their learning, but actually tells the story of phyllotaxis, and it tells the story of photosynthesis, and it tells the story of transpiration, sort of inherent in the building itself. So the next topic I was going to talk about is connecting with nature, or the whole idea of the kind of biophilia hypothesis that E.O. Wilson put forward several years ago, and the importance of actually having a connection to nature in cities but throughout the places that we work and live. And it's something that we feel is very important. Eden is, of course, quite easy because it's all about nature, but even the very first building we built there, we actually used materials from the site. And so it has Gabion rocks, but also the clay is extracted and turned into rammed earth walls. And so the whole building is really grown out of the site. So as you walk down through the spaces, you're surrounded by, the kind of warmth of rammed earth and timber and so on, and gives you, hopefully, that real connection with nature. But that's a kind of very rural setting. But equally, when we did Via Verde, we felt, again, it was just as an important an issue. And actually, the site we were given was quite a tight and difficult site, as you can see here. But it was one of the last bits of greenery, in a way, in the South Bronx. And of course, as everyone is very familiar, the Bronx has had its challenges for several generations. And it's great to see it now kind of emerging as a really vibrant part of New York. And it's, I think, for us, very rewarding to play a very micro and small part of that, but to contribute to that process. So we felt it was very important to actually preserve those green spaces, but also to allow people to have contact with them and to create a kind of oasis, but also to create the opportunity of creating a community that shared a kind of space, if you like. And the brief is actually for a whole series of different levels of subsidized housing, from rental housing to different levels of affordable to-buy housing and so on. And there's an excellent book being produced, actually, by Lance Brown on the whole process that goes through all the other competition entries and the whole evolution of the story. And the interesting part is, I think we were the only team that combined all of those different groups into one building and created it into kind of one, if you like, community. And of course, I could talk about the kind of prefabrication systems we used to keep the building very cheap but very efficient and well built. And we had to build it for the same budget as New York public housing. But the one thing I really wanted to touch upon on this project was the roofs and the terracing gardens. Because not only does it give a series of different facilities, it has an orchard, it has production gardens, it has recreation gardens, but also it really forms the heart of the community, where the community is growing food, and there's a farmer's market at the weekend where where the produce is brought into the farmer's market. And so, it's that kind of connection with nature, I think, that's as important as all the other aspects of the building. But I think, it's something that we look at in many different guises. So, earlier on you saw the Queen's Museum of Art, and that was very much about how you create a museum in a park setting and create a connection to the park. Finally, in 2 weeks' time, we're opening the Fulton Centre, And I first came here to work on it in 2003, where I was told I had to move here with 4 weeks because it was a very urgent, rapid project. I had to move my family very quickly. We got here already, sleeves rolled up, and so we're now finally opening it 11 years later. So not quite as fast as I thought, but the one thing I've learned is patience in New York is sometimes very important. But it was worth the wait, I think. And the interesting part is, because it was federally funded, you can't do an overbuild for various legal reasons. So it's kind of unique down the Avenue of Heroes there that basically there won't be a tall building there. It has access to the sky, and that was a real opportunity that we wanted to take advantage of. And so where many subway systems are always egresses through other buildings, we wanted to take advantage of the fact that we had access to the sky, and it's this sort of hub that connects, all of the subway system down in this part of downtown Manhattan. So right from the beginning, we came up with the idea of creating a device that could capture the sun and reflect it down to the lowest parts of the subway system. So just to orientate you, this is street level here. So this is the main head house building, and then we have this sort of structure that supports this very lightweight reflector on a cable net that then bounces light down to the kind of lowest parts. And I think the important thing to emphasize here is that these projects are all about collaboration. So, on the Queen's Museum, we worked very closely with our colleagues at Bureau Happold on all the kind of light reflectance and how that might work as a system. In the same way, here we worked with Arup and modeled the lighting and looked at how, the sun would move around the site and how we could shape that kind of reflector. So this is and we went through many iterations, I have to say. You can spend a lot of time designing over 10 years. And especially when the client keeps on changing the budget. So, but the net result was actually a very efficient, and we kept the concept, but a very efficient final execution of the original idea. I've got some short little bits of film for you, which gets the idea of the cable net. So here, the cable net, we worked both with Arup and with the engineer Schleich on the net itself. And it was a collaboration between ourselves and the artist Jamie Carpenter. Because once we had the idea of this light reflector, Jamie was brought in as part of the Arts for Transit program. And we worked together very closely on how that might actually work. And he looked at how all those reflectors might actually work and capture light, and other devices might be brought in. So it became much more than just a device for lighting the space below, but it became a whole artistic and sculptural interpretation of that concept. So the wonderful thing about this is that it did literally happen over a period of just a few short days, because the cable net had all been fabricated off-site, so you literally just bring it in and raise it up on two hoops and stretch it, and it naturally forms the shape that it had been designed to take on. And then once that was in place, then we could just hook up all the polished aluminium reflector panels. And these are all perforated to different levels, with the idea being that when you're down below looking up, you actually just see it as an optical device, which you can see here. But when there are two levels of program that sit around that, which will have different uses. And when you're in those, actually the skin is quite transparent, and so it's almost like looking through a veil. So we have this sort of nice optical device where you enjoy one space inside the main public hall and have a completely different experience from behind. So as I mentioned, I think we're just 2 weeks off. I think it opens to the public at 5 a.m. on the 10th of November, so you can all go down and see it then for real. You don't need to take my word for it. So the next topic, design ecology, and again, a New York project, something, we have ecologists that work with us in the office here in New York, but This is a project for Manhattan's water supply. And so this is the Croton, part of the Croton water course. And for the first time, some of the water is going to have to be cleaned and filtered. And it required a very large new facility to be built. And the only place that the city could find to build it was in the park in the North Bronx, which meant building a very large, deep hole, 100 feet deep, very large kind of civil engineering project. And naturally, the users of the park weren't so happy about that. So our role in this was to make the whole thing disappear and to come up with a way of making it disappear and create a new program on top that also provided all the security, because it's a high secure facility. And the initial kind of concepts or ideas was to have, very, very high fences and barbed wire and lighting, which equally doesn't fit in a park very nicely. And so we took, I guess, maybe a lesson from Capability Brown and used a whole series of landscape elements in the form of kind of ha-has and moats and ponds to create all the security. And so this will be the world's most secure driving range, because it has 24-hour armed police. But you'll be able to enjoy and drive your balls onto the roof of the facility. But what protects it are all these ponds that circulate around it. And we were really using it also to demonstrate how you can use plants and ponds as part of a kind of overall ecosystem. So here, it will be one of the largest green roofs in North America. So, of course, you have an enormous amount of water runoff. And so we collect all the water at one pond at one end, and then it gets pumped up to the top of a kind of series of inclined ponds that wrap the entire facility. And it takes about a week for the water to go through each of these different ponds around the facility. And there are different plants carefully selected in those ponds, and it all forms part of a kind of overall ecosystem. And, of course, at the end of the day, the water is stored and then reused as part of the irrigation for the park. So it's really using plants as effectively an environmental system. And it's something that we're keen to do not just in landscape environments, but also within buildings. So this is exactly the same kind of process for a building we're currently working on in Mexico, where instead of having just a landscaped atrium, the atrium is a series of ponds and different planted ponds that actually form part of a kind of water filtration system. So moving on rapidly, I'm just very quickly, harnessing the wind, of course, is something which we can all do and look at, and I'll talk later on about ventilation systems and so on. But the other thing we're very interested in is working with infrastructure. So literally working on, we're working on some quite large-scale power stations at the moment, and we're working on looking at waste to power. And so I think it's something that, I would encourage architects to engage with. It's been left for far too long just with kind of, engineering groups who, of course, are focused on the efficiency and how these buildings work. But nevertheless, how they work also as a kind of, as part of a city or part, and how they work visually and how they sit is very important. And what's happening more and more are these facilities have to come closer and closer to cities. We can't just stick them out in areas where no one worries about them too much. And the closer they come into cities, the more important the design and thinking about how they sit within those cities becomes. This is a research project that we've been working on for a little while, which is looking at a vertical axis air generator, which is kind of inspired, if you like, by a sycamore leaf and seed and how it falls and spins. And, of course, the benefit of a vertical axis system is that it doesn't matter where the wind blows, it's always in the right direction. But more importantly, all the weight and also all the maintenance is at the ground level where you can get to it. And it's part of the UK is looking very seriously at offshore wind generation as part of our kind of renewables policy. And so this is one of those initiatives. But maybe that's a kind of obvious direct way, but also within buildings, there's all sorts of opportunity. And again, looking at natural forms. So this is a railway station we did in Melbourne, and it's part of a kind of overall urban regeneration program, where, as in many places, and we're working currently on several similar projects in different parts of the world, what you find is the railway lines, of course, cauterize a city. and you're either on the right side of the tracks or the wrong side. So there's the central business district. It's basically stops on the railway lines. As happens in many cities, these were the old docks, which have now moved to deeper water facilities, and so this area is now completely regenerated as a new part of the city. So there's a whole urban discussion talking about how you can plan and how you effectively lift over or under and reconnect and reknit the fabric of a city. But for today's talk, I'm just talking about one element of that, which is the environmental system. And of course, the roof becomes a fifth elevation, because when all those new buildings generate around it, they'll all be looking down onto the roof. So, of course, it's an important visual tool. But I think it was the engineer Schleich who said, just because you can doesn't mean you should. And that we often have, now we have all these computer generative tools, that there's a tendency to make shapes just because you can make a shape. And I think from our perspective, it's very important that everything has an embedded purpose. So here, it's not just about creating a curved form because we thought that would look elegant and interesting and create an interesting roof. The form is generated by how it works, in the same way as nature does everything in a very deliberate way. So here, in the same way as you have, I started off showing you sand dunes. In the same way as sand dunes or moguls are created through wind, effectively we're reverse engineering that. And so there are two very strong prevailing winds in Melbourne. And by having this offset mogul field roof and having a ventilated triple skin for the enclosure, the roof form itself does all the cooling for the building and also all the ventilation for the trains below. So it meant we could change the government's reference scheme, which was for a roof covered with mechanical extraction equipment, and there is absolutely no mechanical equipment at all on the roof. So the entire environmental system is actually provided by that roof form and shape. So I'm just, actually, in the interest of time, just going to talk about just two further points. Urban ecology. I started off with the statement about the growth of cities and the challenges we face. And there was a tremendous exhibition at the recent Venice Biennale from Singapore. And I was in Singapore a couple of weeks ago, and it's a city we're currently working in, and a city I greatly enjoy going to. Because, of course, it was originally in the 1960s, they produced a planning manifesto, and it was the city in the garden. And more recently, it's been reappraised, and they constantly do a reappraisal cycle, and they're also now looking at it as being the vertical garden city. But since its inception, and its 50th year is next year as a city and state, it's actually become greener as the population has grown. So that's why I put this up. So it shows you can actually have growth and densification, and you can have greenery and landscape. And so some more recent examples of how that greenery is now not only working horizontally but working vertically. And the proposition in their pavilion was that the population of Singapore is 8 million people. It's very efficient, very dense, and yet has this incredible setting. So in very simplistic terms, you could actually house the entire world's population with 1,000 Singapores, which I thought was really quite a thought-provoking way of looking at it. And I did my own bit of analysis looking at areas. And actually what it means is if you worked on that principle, with still this, go back, large areas of greenery and so on, it means you could actually house, using the same level of density and efficiency, you could house the entire world's population in France. So just a thought. I don't know whether the French would be happy with that, but it's an interesting way of looking at statistics. And we ourselves, I think in the interest of time, I'm actually going to move rapidly on, but have been looking at different planning processes using Voronoi growth strategy, which is a way of creating sort of cellular growth patterns for cities. But I'm actually just going to move quickly on. I think there isn't time to go into too much detail on that. But it allows us to create very dense city plans in a much more traditional way, that are much more pedestrianised, using new transit techniques and technologies that create a more efficient and I think a better way of dealing with dense cities. So finally, just to wrap up, I think in many ways, I talked earlier on about the Eden Project, and how all those school children go every week to learn about nature and science. And that's, I think, one of the things that I enjoy anyway in a lot of the projects that we get to do, is that opportunity, hopefully, to inspire. And currently, again, in the New York office, we're working and building a new science museum in Miami. It's part of an overall regeneration, a creation of a new park. Herzog and de Meuron have already finished the new contemporary art museum, which is here, and we're doing the new science museum. And it's an interesting science museum in that it actually uses, it also has natural history, and it uses ecology and the environment to teach science. But the building itself was really very much inspired by its setting in Miami, which is a city that enjoys partying, enjoys the outdoors. It's a very vibrant and young city, but also has an interesting kind of weather pattern in that it's reasonably benign. But of course, throughout the summer, rapidly during the day, you can get a sudden change in weather, where you go from a hot, humid day to a sudden influx of torrential rain. And so we wanted to create a building that could be very much in contact with the outside, but yet could deal with that. And so in a way, the building is almost like a series of landscape elements. It's actually carved out of solids in a way. And we looked at basically how we could capture the sea breezes, how we could capture the rain, how we could capture different environmental elements to condition the building. And again, this is where I think new computer parametric modeling really can be a very useful design tool, because it allowed us to test out all the forms and shapes and look at and create and effectively sculpt the most efficient different sets of shapes to deal and use all of those prevailing elements on the building. So it really is kind of carved out, if you like, to create a landscape. And the centerpiece is this aquarium, where we have an interesting optic, and it creates the gulf, effectively. And unlike most aquariums, where you look in a glass wall and see fish looking back at you, one's quizzling over the other one, looking backwards and forwards. We wanted to create the experience you have as a diver in the Gulf, where you look up and all you see is infinite kind of volume and fish circling around you. And so we looked at the optics, and basically by having this shape, it means that when you stand below and look into the Gulf Stream, you can't actually see the sides of the tank. All you see is kind of infinite space spreading out and the fish circulating. I guess the inspiration probably was one late night in New York, with a kind of martini glass, but that's just a story. So this will be our next kind of main cultural building that we're just now completing. And again, I think it'll be an enjoyable building. I hope to use. It'll have all sorts of interesting aspects to it. And of course, we were told right from the beginning that Miami is a party city, so we have to be able to host parties and host events. This is an event going on below the aquarium, where everyone's watching the fish above, eating the seafood, and raising money for the museum. So, but I think that really it's also about the impact you can make as an architect in not only creating environmental responses to buildings and creating cities, but also hopefully actually inspiring the next generation that comes to really take the challenges that face us and come up with exciting and innovative solutions. So thank you. So we're going to do some questions, are we? Yes. Right?
I also, before we sit down for questions, I did want to thank Gary Higby and the Steel Institute of New York for this wonderful lecture. So.
Where shall I sit? There? Right. Yeah.
I'm sitting in a hole here.
Thank you, Andrew. That was quite inspiring. Well, my first question was, it's true that Grimshaw, I mean, you were the first firm, one of the first to really engage with these questions of biomimicry and sort of a real kind of inspiration from sort of natural systems. And I'm wondering what has changed, in the technologies out there, in the materials, what do you see as the kind of biggest kind of transformation?
Yeah. Well, actually, I would have to say, first of all, I wouldn't say we were the first. I mean, absolutely. But when I was young, a great inspiration to me was Fry Otto and the work of the Institute of Lightweight Structures, and they did all these marvelous books looking at and exploring natural forms and structures, and the issue I think always was there was a lot of interesting ideas and thought, but the technology wasn't there to deliver on them. So if you look at something like Eden, I would say that's almost us catching up with some of the thinking that was going on almost a generation earlier, where we've now got both the kind of technology and materials to hand, and also the computational devices that allow us to make those all possible. And so I think we're just at the beginning of that, and the exciting thing is that we are literally just scratching the surface. And some of the things we're currently working on, we're looking at even much more ambitious uses of materials and structures and new emerging materials. I think will offer a whole series of interesting opportunity.
Do you ever find that the relationship between form and performance is contradictory, where something would perform better if it didn't have a form that was organic? I mean, when do you decide on that?
Yeah, no, it's an interesting one, because often people say, well, surely it could work more efficiently as a cube rather than a sphere, or are you being governed by an aesthetic rather than its pure performative needs? And I think as architects we also always step back and look at it visually as well, and does it feel right, does it look right? And so I would be wrong if I was to say we don't do that as well. But I think ultimately we are, really are interested in searching for the kind of optimum solution, and in a way, by doing that, I think it creates a greater level of elegance through its sort of efficiency.
I have a question about, I don't know if it's your kind of area of expertise in the office, but I know maybe the students might have, I have an interest in this anyway, but I was interested in how the design team process and how they interact with the engineers, and who might be focusing on the analysis. I know you have the CDU, you have the computational design unit in your firm, and so I was interested in how you work with this kind of shared associative model that you're using, right? That's shared between...
Yes, but I think before that it's actually a bit of paper and a pencil,
right?
I would say. In that, I think that we've always had an ethos, both internally amongst our team, to work in a very collaborative way, but also with our fellow consultants, because it's much more rewarding and interesting. And I think, so we're sitting around the table with, the various engineering disciplines or other areas, and it's a shared design process where I think we might be talking about our views on engineering, and the engineer might be talking about his views on our architecture. I'm looking at Craig over there; he knows the process. But at the end of the day, often, I don't know who comes up with all the different ideas. What's important is that we don't just draw something and say this is how we want to make it work. Go and make it work, because that would be very limiting.
But certainly that Melbourne project, if the roof is really an environmental system in itself, that's a highly
absolutely. Yes.
Designed instrument.
Yeah, you're right. And actually, the idea, we came up with the idea and concept, which was intuitive. And so, does it work? And so that was obviously a discussion with the environmental engineers at the time, who were rather reluctant, but thought it might work. And it was at the emergence of CFD, so it was at the first time where we didn't have to wait until we could do a full wind tunnel testing, so we could actually test it computationally. And I think that's opened up so many possibilities, because it means we don't have to play as safe. We can actually test things as a computer model in a much earlier form. But nevertheless, it was done as a full large-scale wind tunnel test at the end of the day before our client would agree that was the way to go forwards on it.
It was interesting in the introduction by Sir Nicholas discussing about the fascination with the detail and the origins of kind of reusing industrial manufactured items in an architectural context that was kind of using that idea of ingenuity. But it seems now what's interesting is that as a firm you're also really pushing the envelope and becoming on the leading edge of developing new systems. I mean, I noticed that you're, first of all, you have industrial designers in-house, so I would wonder if they contribute, for instance, to designing new forms of hardware, new structural joints in a way to really exploit hyper-efficient systems and so on.
Funny, I was just reflecting on this. I mean, often it's actually an ingenuity needed through economy than it is pushing kind of technology. So, I can think of projects where we've developed entire cladding systems, and it was because there was nothing on the market we could afford.
Right.
And so we've developed our own system, which does it in a much more economical and simpler way. Or, you mentioned the industrial designers. We're designing currently a new furniture system, and it's all about cutting it out of a single sheet of material. So you can laser cut it out of any aluminium or stainless steel or a number of different materials. And the manufacturer working with on it, said, and again, it's a very close collaboration. It means that they can actually cut down their production from 3 different factories to 1. So it means it's much more efficient for them to produce. But I think again, it's actually it goes back to that collaboration aspect. Is that it goes beyond just the kind of consultant team. It's actually also working with industry.
Well, it's interesting that something that might be unique in the project then can perhaps become something mass marketed, and it's a kind of interesting cycle if you look back at the trajectory of the firm. And I think you're correct. It's like finally having so many different hats in the room, so to speak, that can contribute to brainstorming these kinds of things. Do you work with Billings-Jackson in that capacity?
No, well, they used to be one of our sub-consultants many years ago, but that was quite a long time ago, yeah. But yeah, in New York we have a kind of industrial design team that really look principally at that aspect as furniture, but also components within buildings. So, Nick mentioned in his talk Waterloo, for instance, and the scale of it. And that was one of the first times I think lost wax castings had been used in the building industry. And the company that we used to make these quite sophisticated components, what it allowed us to do was have a very complex glass roof made entirely out of rectilinear sheets. So it was actually a very economic and pragmatic solution, but it was all done with quite a sophisticated component. And the company, I remember going up to visit them up in Sheffield, and the other thing they produced en masse was hip bone replacements. So so it shows you the kind of level of precision and really taking something that was really not found until that point in the building industry.
Just following on this idea of a kind of ongoing design research in the office, can you talk about Blue as a publication and the kinds of research you do and how that affects the work and vice versa?
Well, I mean, Blue was really just an idea of actually sharing work with our, fellow architects and consultants in a kind of collaborative way to, help move things along in discussion. And we felt often, as with many, I think, architects, you do interesting work that never sees the light of day. So whether it's research work you're doing or it's competition work where you kind of look through a new area or an aspect of a building that's kind of very much buried within the building. And so the idea was it's not to do with buildings or projects per se, it's more kind of aspects and areas of research on different themes. So, we've looked at environmental systems and structural systems, and often we also write the pieces as essays and so on with our consultants and so on. And so we're rather slow on producing the next one, I have to say, and we're just pulling it together now, which is really a different scale, and it's looking at actually urban ecology.
So it's about the work. You don't set out to research something outside of the work.
No, it's generally pulled together on a theme, and it ranges from very almost, I would say, tongue-in-cheek looking at what if. Kind of ideas to things we're actually doing now and constructing now. So it's quite a broad range, but within the confines of a certain topic of research. And I think we certainly give lots of copies away to all the university libraries, I think. But what we are doing is actually, it's been a printed book until now, and the next one will be digital and print, so you can actually download it from the website.
I was very interested in the infrastructural project, the Croton project. In the end, I didn't know anything about it. And, I mean, it's fantastic to think about something on that scale, and that this kind of conflict of the security can't go there, but at the same time wanting people to go there, and how to overcome that, and the kind of ways in which you were thinking about that. But can you speak a little bit more about what's there, the project for the person
for
who
the
goes
department.
there besides the driving range? Is there
well, it's, I mean, yeah, so effectively, you know, it's...
how approachable it is? How could your idea about how you could live can we live this close?
Yes,
to these kinds of infrastructures? What's the point?
Yes, no, absolutely. So there, it's, you know, it's a very large industrial facility where literally tankers of chlorine are delivered and other chemicals to treat our water that we drink. So you know, so it's an industrial plant, and the only place that we could, you know, it could be located was in a park. So it is in the city, but buried there. And so I think, again, you know, it's the idea of taking a different tact. So rather than trying to dress it up, so you know, you could have looked at, well, how can we deal with the facade, or dress it up, or somehow make it more approachable and sit within the city. By completely sinking it in the park, obviously it totally disappears, and then offers the opportunity to create a kind of different approach with a whole landscaping strategy. And I think also, you know, what we said to the DOE, because the DOE project is, here's an opportunity for you to demonstrate best practice, and to demonstrate how you can actually harvest and collect water and actually use natural systems and plants as part of an ecological system that cleans and filters water and also adds to the biodiversity of the park. So not only, you know, it's not a question of having to have this big facility, but the facility's gone, and actually you've now enriched and made the park a kind of better place.
Good thing for the DOE that they
yes.
thought about
And
architecture
actually,
too.
like Fulton Street, it's a project of love and time. So I think we've been on it for about 7 or 8 years so far, with another 5 to go.
Can you tell me a little bit what didn't go forward with Fulton?
Well, no, very, very
I
little,
think it's
actually.
just interesting for the students to understand, like,
Yeah.
what happens in 11 years that
I'll try.
we
Right.
don't see.
11 years and 1 minute. Our initial concept, and the model is actually sitting in our kind of gallery space on the ground floor, was to create the head house building and to create effectively a dome. It's not a unique idea to have a dome with an oculus on top that captures light, but to have a dome with an oculus that captured light and reflected it down to the lowest levels. And so I gave a presentation at the downtown centre, the AIA, and it was, you know, in the New York Times, and everyone was very pleased, and that was great. And so that was the building done, and we were continuing on our environmental impact assessments and so on. And until all of that was done, the MTA couldn't buy the land. And in the meantime, Tribeca became a very popular place to live. Prices started soaring, and what were shops and so on actually had to be valued as best values. In other words, they valued whatever you'd get as the highest value under a compulsory purchase, which was housing. So in simple terms, a few months later, as we finished this process, our client came back to us and said, we have this much in our budget to buy the site, and actually the site's costing 10 times that. So we like everything in we like the ideas, we published them and everyone likes the ideas, so we don't want to change anything, but you just need to make it a lot cheaper. As many practicing architects in the room know, and for the students you'll be finding out very soon, this is not uncommon. So what we said was, well, okay, we can create a level of, we'll keep it, it will be as elegant, but it'll be economically elegant. And so, in simple terms, the dome was actually quite a complex, compressive structure. And so we kept the idea, but made a much simpler cone, which meant it was much easier to fabricate and build. And then all the work's done by that cable net inside, and that gives us all the geometry and form. And so it meant it was, using, a bit like, actually Eden was the same process. Originally it was a glass and steel roof that just was costing way more than the client could afford. And we had to find a solution that they could get everything they wanted to for about a kind of a quarter of the initial kind of estimates, if you like. So Fulton Street was really that process, but also then as importantly, I mean, hopefully what you'll find when you go down below is there's some interesting use of materials. So we have GFRG, which we're using as part of the kind of ceiling systems, cladding systems, which I think has got huge opportunity in transit buildings in the future. So it gives us kind of very robust but interesting and well-detailed interiors. So we managed to hold on to all of those elements, because there's a real risk that very quickly you're told this is our normal palette. You know, go and look at some of our other transit stations, and what we'll have is what they call tile and smile. And so we managed to hopefully hold on to the kind of quality of interior, so that, you know, because it's such a unique opportunity, because seldom do the MTA get to build a complete standalone transit station where you have contact to the sky.
What's so amazing about the enclosure of the Eden project, and then again the cone replacing something perhaps more conventional in a sense of a kind of transparent dome, is that this, you know, they say necessity is the mother of invention, but I think it also shows that when architects and designers kind of are pushed to the limit and use creativity to maintain a certain design intent, that, you know, perhaps better results.
I think that's a very good way of putting it. Yeah. Well, yes.
And I would carry that to Via Verde, which was also really interesting in terms of ingenuity with the materials. And has that had a kind of follow-up? I mean, were you invited to do more housing, or has that changed some of the kind of practices in housing in New York? Or
I mean, hopefully it will do. I mean, we have done, and we haven't taken up the office yet. But we're looking at some other, some other kind of very interesting opportunities of creating kind of low-cost housing. So I think, again, it's almost a kind of responsibility for all of us to engage in those opportunities, because it's very rewarding to do a Miami, or to do a nice museum and so on. But probably as important, for the future of our cities, to kind of engage in trying to get the best quality design we can, but economically. And I mean, I particularly like when Michael Kimmelman wrote a very nice piece about it, talking about the role it plays, which is really not thinking so much about architecture as a series of icons in the city, but thinking of them as part of a fabric in service to creating a city. And I think that's an area we're really interested in. I mean, doing something as humble as Nick showed the little bike racks we did downtown.
You guys did that.
Yes, and I mean, actually, that's part. That's part of a strategy. It's actually to stop flooding. So we were asked to come up with a solution to stop the subway system flooding when we get torrential downpours of rain. Well, it's not quite robust enough for super hurricanes and so on, but it does stop very big downpours. And we wanted to turn that need into a kind of amenity. And so hence, the seats and the bike racks and so on, and they've become very populated and quite popular.
Cool. Should we maybe open it up to the audience?
Craig has a question.
Could you discuss your windmill is contrasted with the standard wind turbine, which kills birds and is noisy and has light pollution and such? It seems like yours is much nicer, but is it efficient?
I'm glad you thought that. That's great. Yeah, I mean, again, it's still under research, and again, it's all about collaboration, because that's we've been working with the engineer Arup and with Cranfield, which is a kind of major research university in the UK, and so it's again a balance, because it means the weight, if you like, is down at ground level effectively, or low down, and also means the maintenance is low down. But there's a play against the kind of efficiency in that and the velocity of wind it needs to make it work at certain efficiencies. But with all these things, what you tend to find, what we've found, is that the existing technology is extremely entrenched. And so all the turbines are sold primarily by a few very large companies who are extremely committed to what they've already done. So, Siemens is one. And they've invested heavily, and so the difficulty with this type of technology is actually getting somebody to take it on board when they're already so committed. And what we found in other areas is you almost need to find somebody that's not in that industry, that's interested in getting in that industry, that's actually wanting to be disruptive. and actually looking for the opportunity to be disruptive. And so, but that's that. You know, it's not easy.
I'm interested. I always see your architecture and the history of the firm as being, initially about componentry. The details around these things and how you can kind of grow a system from, basic building blocks. I mean, Nick described it really well. How does that affect you as I see a lot of your work start to go into urban scale? Like, what's the equivalency of that componentry in an urban scale? How do you build a project from these basic building blocks? It's not a piece of furniture anymore.
I think it's an interesting area, and I think so our approach to, if you like, urban design maybe comes from a slightly different direction than others. In that, maybe one approach is a more formal approach to do with geometries and so on. And what we're particularly interested in is two parts. One is the kind of infrastructure and how environmental systems and closed loops and so on, and how actually at a city level you can create really efficient solutions, and looking at densities and transit systems and transport systems and how those systems can layer to govern how you would plan a city. But I think the other area actually is culture and programming. So we have a very close alliance with a company, group called Future City, which we've done the Urban Research Unit with. And there it's actually looking at how program can also create a sense of place. In the way that traditionally museums or other cultural institutions can actually create a sense of place, you can actually use that to create a place where there is no place. So, I'm going to be very interested to see how our neighbour, the Hudson Yards, for instance, how that actually develops and how that really creates a new part of the city. We've been working over the last 6 months or so with the Municipal Art Society, looking at the whole West Chelsea area and actually mapping all the different cultural uses and actually trying to develop and build up how you can use culture and those sort of programming elements to create a new part of the city in a sense of place. And the way that you see, for instance, the kind of galleries moving into that area, starting that kind of seeding and that process.
I'm wondering that how you feel the relationship between the technology, nature, and human.
Technology, nature, and human. I guess technology to me is just a means to an end, and I would use the word ingenuity rather than, if you like, innovation or invention, in that it's actually more to do with using what's appropriate. So, I deliberately cited the two examples of the Eden Project to show two ways that you can actually use ingenuity, but using different materials and different levels of technology. So, one is using the very latest at that time technology in lightweight structures and environmental systems, but to the same effect, creating an architecture using literally mud and wood. And both are as valid. So I would say the relationship man to nature is technology is one of the ways, but it's really using our mind and doing things in the most ingenious and going back to my starting point with the kind of rainforest, in the most ingenious and efficient way as we can, so we can actually live in a kind of sustainable way with the planet.
But I wanted to follow up on that, because I actually think, and to follow up on the performance form question, because it seems to me that where the work it moves away from technology and enters into a kind of cultural realm is where, when you make the decision that a certain form may convey a relationship with nature that another form which might perform better wouldn't, right? I mean, it's not like you're just engineers kind of going for the most, not to say, but going for the most efficient.
Craig wants to interrupt
I mean, there is a cultural dimension of like this is what nature feels like or looks like, and you're interpreting it. So that, I think that's a very interesting part of the work that gives it its aesthetic quality, which is very different from another firm that might want to achieve the same level of performance.
Well, it seems to me that the biomimicry is not so much on the aesthetic appearance of natural forms. It's rather more the processes and the systems that are essentially extracted, reinterpreted, and given another form.
Yeah, absolutely, and that's why I use the term inspiration from. So because biomimicry sort of suggests mimicking. And I think for us it's a subtler thing. It's actually an inspiration from nature, whether that's just to do with the level of efficiency or as you talk about the kind of elegance you find both in natural forms, but also, you're right, as architects we have a kind of cultural responsibility within a city and within the design that we do, and so it's not a simple one-liner, is it? It's a complex set of layers that you're working with in designing, working in architecture.
I'm impressed by the performance of the design that you presented. I have a question that, because almost all of the design for inspired by nature is about the recent technologies and the innovations, and at the beginning you show some kind of mapping and a photo of Beijing that is really contaminated. And all these growing cities in the future will be in Africa, in India, in Middle East, and in China. So what's your view on those continents that are happening? Because most of your projects or your office are in Australia, in London, and in New York. Yes.
Well, I guess I was showing work that we're predominantly doing out of New York just because of the context here. We're actually doing out of New York several projects in China currently. But the problem with all those things is that you can't show them or talk about them. So that's why I haven't shown any of them.
Nobody will know.
But eventually you'll see them. But you're absolutely right. I think the issue there is that there lies the challenge. Well, there are two actually. So we have the emerging countries and emerging economies, where there's, in a way, an opportunity to start with a blank sheet and to do things in a more efficient way, and I think certainly some of the things we're looking at in China, that those opportunities or challenges are being addressed. But also, I think equally interesting is how do you re-engineer or recalibrate existing cities. So, a city like New York actually has everything there because it's very dense, and so we can make it very efficient, but it isn't really that efficient at the moment in some respects. So how do we also work within the existing fabrics of our cities? And even more challenging probably in Europe, where you're working with kind of medieval cities or medieval street patterns, or London is a good example. So how do we make both our existing cities as well as our new emerging cities much more efficient? And that's, I think, a discussion for an entire symposium, really, so I don't think I can answer it in a short answer.
Hi. Towards the end of the Sir Grimshaw's introduction, he talked about there's a bit of things up for debate, where is that when people go to work, for example, there's a new details, people feel more happier. So, and during your presentation, there are several projects related to urban renewal. Mm-hmm. So that goes to the topic of gentrification, which I think is quite related to Sir Grimshaw's that kind of belief as well. So what do you think? I think Tribeca was a good example. The rent was going up.
Yeah, that's what. But conversely, I use Via Verde for instance, where standard public housing is not, it is what it is, and there's an opportunity to demonstrate you can actually do economically, but really elegantly designed and I would say well put together, architecture that really improves people's lives. And certainly, the initial kind of feedback we've had is that it was oversubscribed several times over. People wanted to live there. And the more interesting thing for us has been going back. And I think actually, I have a feeling Colombia, I'm trying to think we're commissioning a post-occupancy study looking at how it's gone over the last 2 years and whether it's what's working and what isn't working. So part of the kind of architecture there was looking at how we can build something so affordable, which we did a lot of prefabrication. So you'll see on the kind of paneling systems. We also use materials such as wood in a kind of different way to create a kind of warmth. So the inner courtyard uses a lot of wood. The outside uses more kind of aluminium panel systems and so on. So, back to Nick's point about good details. That is important because a well-detailed building will stand the test of time and will weather well. And something that falls apart and looks dreadful makes me feel unhappy anyway. So so I think for everything and all the elements we use in a street or go and buy a newspaper, it's much nicer to go to a nicely designed newsagent stand than it is to go to some decrepit old falling apart newsagent stand. So there we are.
Yeah, I agree on those, but I think my point is more towards say. The things we as architects cannot control, but it's the rent going up, the land price. It's not the fabrication price.
Which is, then you're moving really into public policy, aren't you, and control? Because and it's a big issue in London, and an emerging issue, I think, in New York. So actually, I'm going to be interested to see in West Chelsea, where we've got our first I think Zaha's building a big apartment building very near us. And when it gets sold, I'll be interested to see how much of it lights up at night. Because what's happened in London is that all of these sort of interesting high-end apartment buildings are sold, and they never light up at night. And so we've got a new kind of phrase in London which is called zombie land. And so all those areas where you've basically got large tracts of the city where no one lives because they're investment properties, and they just basically might light up a week a year. And what that means is that then all the kind of shops and things that make a city vibrant just disappear by the wayside, and so you just have these vacuous parts of a city, which I think is your point. But the trouble is that's beyond our control as architects, and we're into urban planning and
But in terms of policy, I thought it was interesting that you made a note that you integrated the 3 or 4 different levels of rental market and different levels of affordability and so on. I take that wasn't a mandate in the RFP.
No,
it wasn't.
And so that I think that's important that you as an architect took a position that you may risk actually losing the competition because it might be, beneficial for the developer to be able to get a higher amount of market rent by not integrating affordability and
actually,
so on.
I think the interesting part of that competition was it was a developer-architect competition. So we were working. So again, it relied on a good relationship. So we were working with Phipps, who are a non-for-profit affordable housing, and Jonathan Rose. And we've done quite a lot with Jonathan over the years, and and he's obviously a very enlightened developer. But because you're right, it's got and I suspect the reason it's actually an interesting book because it shows both the initial concept ideas for the first round competition and the second round competition, and to see how the different architects approached it. But it might well have been that the reason why one of them did as 3 distinct blocks wasn't just to do with the way they thought it should be, because probably the developer they were with as well was saying, well, my market rate townhouses can't possibly be connected to the low cost rental. They've got to have their own identity and entrance and so on.
Maybe should we take one more question?
So I think I want to point out a couple the use of the word nature. It does tie into what we've been talking about. That it has a lot to do with the cultural reading or the image. So for me, nature is a kind of image people have of something that's out there. And I wonder if the firm is interested in more biological processes instead of the ones that are just natural. So for example, I think any firm that uses computation as much as Grimshaw is already dealing with something that can approximate biological behavior, such that biological systems create complexity through many millions of very simple interactions, and that's how the computer generates complexity as well. And it's almost right under your nose, this other level of
inspired by nature, which is, it's like one black box lower. I wonder if you've experimented or have considered another level, like a sort of deeper, a deeper reading of nature as more of a process of growth or you know, and not starting from the seed of the image and then testing the image, but
So of course, the one project I skipped over to save time would have answered your question, which is the Voronoi tessellation. So I mean, because it really is what you're saying is that, you know, there we were looking at creating using computational systems to create biological patterns effectively that allowed us to create very dense kind of city planning, but one that didn't have a if you like, a prescribed end result. So it had sufficient flexibility that actually changes over time, and what we've mapped was how it would change over 30 years. So you could actually grow in the same way as actually cities have always grown often out of towns, and a series of towns that have then grown and then merged into them to form a collective that then becomes a city. We were interested in how you could actually use kind of natural, you know, and there the natural form there was kind of the Voronoi tessellation to do just that. So that's at a kind of urban planning level. But and again, we were looking at it on a couple of other things to do with the opportunity for kind of growth that is not prescribed now, but can grow in different ways, which I think is where you're coming from. So you're looking at kind of systems rather than just kind of environmental solutions.
All right. Well, thank you so much, Andrew. That was really inspiring.